This is my Chinese K40 Laser, which is a remarkable bit of kit, but the engineering is just awful. It's abysmal. And on this particular model, or this particular one, mine, there's a lot of play on the y-axis guide rail. So if I hold this end of the rail here, you can see that this end just wobbles about, and it produces an awful result on circles. So I've taken the decision to build a new frame for the XY rails, and I'll utilize the existing mirrors, focal lens and all the electronic gubbins. I'm also going to look at the idea of removing this partition so that I can extend the frame into here, so it'll give me a larger cutting area, and then I'll find somewhere for the power supply and the PCB and the controls, probably up above. And I'll put some thought to that and I'll get back to you. Okay, this is my frame, and I challenged myself to build a frame with the same footprint as the existing Laser, including the fan at the back which sticks out. And I've managed to achieve this. It's slightly shorter than the existing K40 Laser, but slightly deeper, so it's more or less the same footprint. And I've built it using this and this. I pretty much rejected the aluminium extrusion method because it's quite expensive, whereas this is relatively cheap. And it's based on a right angle joints, and like this. This is a four-way joint, and you can get straight connectors, two-way, three-way, four-way, five-way, and even six-way joints. And this steel tubing, this is 25mm square with a 1.2mm wall thickness, and it comes in various colors. And you just put it in like that, and then tap that into there, and that's your joint finished. Well, it is your joint finished if you're using it for a countertop or something like that. But if you're on a precision, if you want a precision frame which needs to be perfectly square, then it does need fixings and it does need squaring up. So what I thought I would do to keep this frame square, because the whole principle of this now is that this is all the size it's going to be. The cladding is going to go on the outside, so everything else has to be on the inside. I didn't want to build a frame for my XY rails and then have to build another frame on the outside for the cladding. So this is a dual purpose frame. It's the cladding on the outside and the X and Y rails on the inside, which means everything else has to come on the inside. So I've tried to think of a corner brace that would occupy just the minimum amount of space in the corner. And I came up with the idea of using this. And I bought a short length of this, and that's 100mm by 5mm. And I cut some 25mm slices off to put on the corner. And I was either going to put it on the outside or on the inside, probably on the inside. And then what I did was I put a strong back, I screwed a strong back to this temporary worktop, and I put another strong back screwed down here at right angles, and I clamped this to the strong back, and I clamped this to the strong back, so I knew that that was a perfect right angle. Then I put that into the corner, and I clamped that into the inside of this and the outside of the strong back in both directions. So I knew that that was perfect. Then I went to the other corner, and I clamped this in place, that this arm going down there was way out. It was about 5 or 6 mil out at that end. So I stripped it all down again, measured everything up, put it all back together, checked the strong back angle, it was perfectly 90, reclamped it all, re-put that in, and lo and behold, it was exactly the same. It was out 6 mil in that corner. So then I put a square on this, and over that 100 mil, that's down 1 mil. So then I looked at all my other bits of aluminium that I've got hanging around, well, the angle aluminium, and I put a square on them all, and they're all out. Not one of them is a 90-degree angle, and I assumed they would all be a perfect 90-degree angle. So here's a universal truth. Aluminium angle is not 90 degrees. Always check it if you want to use it as a 90-degree angle. So anyway, I discarded that, and I found these instead. These are purpose-designed corner braces, and you can see it in there. And these are perfect 90 degrees, and this frame is now a perfect rectangle with square corners. For my X and Y rails, I'm using these. I bought these off eBay for a very reasonable price. I think I paid about £40 a pair for those, and £35 a pair for these. This is based on a 15 mil rail, 15 mil diameter rail, I think it is. Yeah, 16 mil diameter rail, and this is based on a 12 mil diameter rail. And these are all now floating perfectly. Whilst it's down in this position, of course the CO2 tube is going to go in the back there. And I'm just beginning now to put the brackets on for the mirrors. That's a support bracket, and this will be the mirror bracket. That will go onto there like that with the mirror. And that will be at the same height as the focal lens mirror. And what else I'm going to do is I'm going to, on the K40 laser, the motor, the stepper motor for the y-axis is in this bottom corner, and the tension adjustment is up there, and you can't get at it. It's almost impossible to get at it. So I'm going to move this motor from here to there, and then put the tension adjustment here, and then we'll have an extended rod across there for the slave cog, and that will also have its tension down here. And the motor for the X-rail is going to go underneath there and pop up here, and there'll be a little tab under there to join, and the tensioning back here. So there's not really that much more to do in the engineering of it. And I'm quite pleased with what this error I've done already. I mean, that's just there's hardly any energy needed to move that, and even from here, there's hardly any energy needed. And I suspect that the stepper motor alone, without the slave drive, would be enough. But anyway, I'm going to put the slave drive on because it's better engineering. And that's as far as I've got.